Hello everyone, this is Amitkeerti here. In this video I would like to talk about a sorting technique called as BubbleSort. So we will be looking at BubbleSort here. Um, the items for discussion would be BubbleSort introduction, a BubbleSort example, BubbleSort algorithm, understanding the algorithm with an example, and then finally we will look at the time complexity analysis. Now, bubble sort is generally the first technique that is taught when sorting algorithms are introduced. So this concept of sorting is generally explained as the first method of sorting. So it's a kind of easier way of getting into the concept of sorting. So let's look at bubble sort example now. So here are a set of numbers which are not sorted. Let's see how bubble sort works for these set of numbers. Basically, bubble sort aim is to pick two numbers, adjacent numbers at a time, and check the smaller, whichever one is the smaller, then choose that number as a smaller one. And if for example we take 89 and 45, the smaller of them is 45, so 45 gets chosen, then 45 is compared with the next element. So if since 45 is smaller than 68, we will interchange 45 and 68. If we our aim is to move the bigger element, then probably when we check 89 and 45, since 89 is bigger than 45, 89 moves to the right and 45 moves to the left. So we will just go through this example here. So first 89 and 45 are checked. Since 89 is greater than 45, 89 moves to the right and 45 moves to the left. And then 89 and 68 are checked, and 89 moves to the right, 68 moves to the left. And since 90 is greater than 89, 90 stays there. Then 90 and 29 are checked, and 90 moves to the right and 29 moves to the left. Then 90 and 34 are checked, and 90 moves to the right and 34 moves to the left. And then 90 and 17 are checked, and 19 moves to the right and 17 moves to the left. So by the end of first iteration, the biggest element is moved to the right, which is 90. Then during the second iteration, we again start with the same set of numbers with 90 which has already been sorted. Then we check 45 and 68 again. Since 68 is bigger, it stays where it is. Then 68 and 89 are checked. Since 89 is bigger, it stays as it is. Then 89 and 29 are checked. Since 89 is bigger than 29, 89 moves to the right and 29 moves to the left. Again check 89 and 34. 89 moves to the right and 34 moves to the left. Then again we check 89 and 17, and 89 moves to the right and 17 moves to the left. So by the end of second iteration, the second biggest element has been moved to the right. So then for the third iteration, we again start with the first two elements. Since 68 is bigger, it stays as it is. 68 and 29 are compared, and 29 moves to the left and 68 moves to the right. Then 68 moves to the right and 34 moves to the left. And then 17 moves to the right and 68 moves left, and 68 moves to the right. So 68 is also sorted. And so in the fourth iteration, we again do a similar operation. And 34 will move to the left and 45 moves to the right. 17 moves to the left and 45 moves to the right. So 45 is sorted. And so in the next iteration, again we check 29 and 34. 34 is in its place. Then we check 17 and 34. 34 moves to its place, and 34 has been sorted. And then in the final iteration, we check the last two pending elements, and we move 29 to its place and 17 to its place. So by the time 6 iterations are done, all the elements are sorted. So the basic aim or the reason why it is called as a bubble sort is because the heavier elements start settling down and the lighter elements start moving up, or rather bubbling up. So since this looks like as if lighter elements are bubbling up, that's why it is called as bubble sort. Now, this is the algorithm for BubbleSort. This code has been written in C. So you will see that the function bubble takes an array as a parameter, and it also takes n, which is the number of elements, as a parameter. And then there are two for loops. The outer for loop is for the number of iterations, that is 6 iterations that we saw, and the inner for loop is for comparing the adjacent elements. That is, in the previous example we saw, we compare first and second, second and third, third and fourth, and so on. So the inner for loop is to compare the adjacent elements. So you will see that in the inner for loop we have an if statement which compares the when j is equal to 0, it compares array of 0 with array of 1, and if array of 0 is greater than array of 1, we exchange the 0th element with the first element. So by doing so, the greater element starts moving to the right. So as the for loop keeps increasing, the bigger of the two elements keep shifting towards the right, and then finally after say first iteration, the biggest element would be on the right hand side. Now you also see that j goes from 0 to n minus 2 minus I. The reason being that every for loop, as I keeps increasing, the right hand part should stop from wherever we have already sorted. For example, after the first round of iteration, the first element or the biggest element would have been sorted to the right. So we need not compare that element during the second iteration. So that is why as I keeps increasing, the j's value, maximum j value up to which the inner for loop has to go, will also keep reducing. So we will see this more when we again take this code and then look at the same example that we had seen before. So let's take the same example that we had taken before, and let's take the code again. So here you will see that initially I will be 0. So j goes from 0 to 0 to 7 minus 2 minus 0. So that is equal to 5. So we will check from when I is equal to 0. So j iterations goes from 0 to 5. So 0 to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5, and 5 to 6. And then if the element is bigger, that's the element on the left hand side is bigger than the element on the right hand side, then we will swap. So let's just take the same numbers. So when I is equal to 0 and j is equal to 0, we will check 89, that is a of j, with 45, that is a of j plus 1. And since this value is greater than a array of j plus 1, we will go and swap the elements. Then j becomes 1. Then we check array of 1 with array of 2, and since array of 1 is greater than array of 2, we will swap. Then when j becomes 2, we check array of 2 with array of 3, and since they are same, we will not, since 89 is smaller than 90, we will keep 90 as it is. And when array of when j becomes 4, we check 90 and 29, and since 90 is greater than 29, we exchange. And then when array of when we check 90 and 34, 90 moves to the right and 34 moves to the left. And then when j is equal to 5, we check 90 and 17, and so j will be 5, so j plus 1 is 6. So 90 and 70 we would do an exchange. So this is when I is equal to 0. So the first element would have been sorted. So when I becomes 1, j goes from 0 to 4. Since 90 has already been sorted, we need not go all the way till 90 and compare the last element as well, because this element has already been sorted. So again we start from j is equal to 0 to 4. So when j is equal to 0, we compare array of 0 with array of 1, and then we keep it as it is because 68 is greater than 45. Then when j becomes 1, we compare array of 1 with array of 2, and we retain as it is. Then when j becomes 2, we compare array of 2 with array of 3 and we exchange. And then subsequently we will do the same thing for 34 and 89, then 89 and 17, and 89 gets sorted. So 89, we will not compare 89 and 90 because there is no reason to compare. So j would not go all the way till the end because 90 is already sorted. So now two elements are already sorted. So again, when I equal to 2, we go from j is equal to 0 to 3. So when j is 0, we will compare these two elements and then these two and interchange, these two and interchange, and then we will compare these two and then we would interchange, and 68 would actually go and get sorted in its place. So this process would continue further. So as j keeps increasing, we would limit our inner for loop only till the elements that have not been sorted, and we will not touch this part of the array. Now let's look at the time complexity analysis of BubbleSort algorithm. In the code that we just saw, the basic operation is the if statement, and time complexity is generally the number of times the basic operation gets executed. So since the basic operation is if the left hand side element is greater than the right hand side, so since for both for loops this is the statement which gets executed every time, we treat this statement as the basic operation. So if you look at the number of times this basic operation gets executed, you will see that in the inner for loop, since j goes from 0 to n minus 2 minus I, so for each of the inner for loops, this basic operation would get executed once, and the outer for loop goes from I is equal to 0 to n minus 2. So for each value of I, the inner for loop goes from 0 to n minus 2 minus I. So this is the way we can write the equation for the number of times the basic operation gets executed. So C of n will be equal to sigma I goes from 0 to n minus 2, which is the outer for loop, and within that sigma j is equal to 0 to n minus 2 minus I of one time each the basic operation gets executed. Now we know for a fact that sigma j is equal to 0 to n of 1 can be written as upper bound minus lower bound plus 1. In this case, upper bound is n and the lower bound is 0. So we can write sigma j is equal to 0 to n of 1 as n minus 0 plus 1. So if I take an example, for example, sigma of summation of j is equal to 0 to phi of 1, it would be actually upper bound, which is phi, minus lower bound, which is 0 plus 1, which is equal to 6. So even if we do it by hand, the calculation will be 1 plus 1 plus 1 plus 1 plus 1 plus 1, that is from 0 to 5, which is 6 times. So it would be 6. So if we apply this particular learning onto the inner summation, we will see that this inner summation is nothing but upper bound, which is n minus 2 minus I, which I have written here, minus the lower bound, which is the 0, plus 1. So the inner summation has been written as n minus 2 minus I minus 0 plus 1, and the outer summation stays as it is. And suppose I solve this to so minus 2 plus 1 will become minus 1, and the n stays as it is, and then minus I would stay as it is. So when I solve the inner summation, I would actually get the equation as summation of I is equal to 0 to n minus 2 of n minus I n minus 1 minus I. Now if I substitute I is equal to 0, 1, 2 in the above equation up to n minus 2, I would actually get like this. So I am substituting actually I is equal to 0 here, so I would get n minus 1 minus 0. Then I would substitute I equal to 1 here, so I would get n minus 1 minus 1, and so on. And then finally when I substitute n minus 2 here, I would actually get n minus 1 minus of n minus 2. Now if I solve this, so it will be n minus 1, this would be n minus 2, and this will go on till 2 plus this n and n would get cancelled, and this will be minus 1 plus 2, which will be plus 1. So the number of times the basic operation gets executed can be written as n minus 1 plus n minus 2 plus up all the way till 2 and 1. Now we also know that 1 plus 2 plus 3 plus up to n can be written as n into n minus 1 by 2. Now if you compare our equation with the general equation, the difference is that here we don't have an n, so we are lacking an n, whereas there is an extra n on left hand side. So what we can do is we can subtract n on both sides of this equation. Then when we do that, on the left hand side we will get it as 1 plus 2 plus 3 up to n minus 1, and on the right hand side it will be n into n plus 1 by 2 minus n. So on solving this, we would actually get n square minus n by 2. So 1 plus 2 plus 3 up to n minus 1 can be written as n square minus n by 2. So suppose I substitute my equation, I can actually write it as c of n is equal to n square minus n by 2. And we know that this is of the order of theta of n square. So basically the complexity of bubble sort actually happens to be theta of n square. Now this since BubbleSort does the operation in theta of n square, there are a lot of critics of BubbleSort who believe that BubbleSort is not the way to do sorting operation, and it should actually be banned from being taught in universities and various places, because it is not one of the most efficient way of solving things. So in summary, this is what is bubble sort. It's a way of sorting elements such that during each operation the lighter elements start bubbling up and the heavier elements will start settling down. So by the time you finish the iterations, you will get a sorted list of elements. Thank you all for watching this video. I hope you had a good time and you enjoyed watching this video. Thanks.